My name is Sandi Barr, and I'm here today to talk to you about automating accessibility assurance. So, accessibility testing is often thought of as an afterthought. It can be considered technical debt to be done at the end of a project after that software is built. But waiting until development is completed can be costly, and it leads to unplanned rework that only increases the time to release. Instead, if we account for the accessibility requirements from the start of a project and create test plans based on those requirements, we can then automate tests to ensure that what we deliver is actually accessible and continues to be accessible as it scales and evolves over time. The Web Content Accessibility Guidelines, WCAG, is an international standard developed by the World Wide Web Consortium, W3C. Web Accessibility Initiative, pronounced WAI, that explains how to make web content more accessible to people with disabilities. WCAG defines 3 levels of accessibility conformance. AAA is the highest level. It is considered to be maybe not a required policy for all websites because it can be difficult to meet the level of success criteria for some content. For example, the contrast ratio between your text and background colors must be at least 7:1. That's pretty high. And pre-recorded video content must have a sign language translation and an audio description. Websites that meet AA standards are considered to be reasonably accessible. Text and background colors have to have a minimum contrast of 4.5:1. Content must be presented under clear headings in a logical order, as in H1 followed by H2 and H3, etc. And elements that affect navigation should be consistent across the site. Websites that meet level A, single A standards, meet the minimum level of conformance, and this is considered to be basic accessibility for every website. This includes keyboard navigation, providing equivalent text for non-text content. Form controls need to have labels, content must be accessible by screen readers, and information should not be conveyed through size, shape, or color alone. A11Y is a numeronym. It's shorthand for a word where the abbreviated letters is replaced by that numeral. It's like Kubernetes or I-18N for internationalization. Although this can be much easier to type, using A11Y in place of the word accessibility is not actually accessible. It fails the 311 WCAG success criteria for unusual words because certain disabilities can make it hard to understand non-literal language. By automating assurance, I mean the programmatic automated tests as opposed to manual testing performed by a person. Automated tests can validate in a matter of minutes that a new set of changes don't adversely affect accessibility. And continuous integration pipelines can automate these checks on code repositories that reduce defects and ensure that software is delivered reliably. Have you ever wondered why our websites aren't already accessible? Why is it that we hesitate to solve this problem? For one, it can be pretty hard. As engineers, we're not all experts on accessibility, and the majority of us don't experience the visual or other impairments that require the use of assistive technology like screen readers. So then we kind of assume that the majority of our users aren't experiencing these challenges either. Another reason is it is considered to be sometimes too expensive. Everything from the cost of enterprise testing tools to prioritizing and actually taking the time and effort. And often, we get too stuck on design decisions. This is not meant to be any offense to any designers in the room. I'm not, directing this at you. It's just that once decisions in design have been made, they're often very hard to change. So the good news is we don't have to do all of the heavy lifting ourselves. Today, I'm demonstrating these free and open source tools to assist with accessibility testing and ensure conformance with WCAG standards and success criteria. First, we're going to take a look at ESLint plugins that validate accessibility standards are met by performing static code analysis directly on the template code. Then I'll show how user-focused testing with testing library ensures accessibility with your unit tests. And finally, we'll add the Axe Core accessibility engine that automates accessibility testing against a fully running web application in end-to-end tests. You can use these tools in React, Angular, Vue Workspace with Vite test, in Vite or in NX with Jest, or in JS DOM. So first up, I'll show how the rules in these ESLint plugins assist with accessibility by giving developers feedback directly in the code early on in the development stage. ESLint is a static code analysis tool that can efficiently audit code and flag problems based on assertions that are called lint rules. These rules run against your code base, checking to ensure the specific standards for each rule are met. These particular ESLint plugins are framework-specific because they parse and evaluate framework-specific template code, but generally accessibility testing is not framework-centered and is about what we create on the web with these frameworks. So I just wanted to make that caveat. So there's a comparable recommended accessibility rule set in each plugin that can detect many accessibility issues. The React plugin, JSX A11Y, is where the rule set was originally developed, and so it has the most comprehensive set of rules. The Vue plugin came later and it actually superseded a prior Vue plugin that's no longer maintained. And the accessibility rule set for Angular is in the Angular ESLint template plugin, which would be installed for you if you're already using Angular ESLint. I myself am a contributor to these rules on Angular ESLint. ESLint plugins must first be installed via NPM or with your preferred package manager, and then enabled via configuration. Many popular workspace and build tools come pre-configured with ESLint and its recommended rule set. These plugins can then be added to the recommended configs using the extends configuration. Configuration settings for the various rules can then be applied as needed in the rules configuration property. For Angular ESLint, the template rules are configured inside the HTML files section, which applies the configuration to both inline template code and separate HTML files. You want to take a look at and follow the instructions for your plugin with your framework and workspace style. So, for example, there's an ng-add schematic for Angular workspaces, but if you're using an NX workspace, NX will set up this configuration for you. So let's just go ahead and then get into the rules. This first rule, alt text, ensures that images have alternative text. Image alt text should serve the same purpose and convey the same meaning or intent as that image. It should not repeat image information from the image caption, and it's important to use empty alt text when we have a decorative image. It's appropriate to use empty alt when there is equivalent text provided adjacent to the image and the image itself no longer has any additional meaning for non-visual users. I got so much time to tell you about alt text. I have lots of opinions on it, but I wanted one thing to note, that to screen reader users, less is more when it comes to your alt text. You should be using no more than about 125 characters. And it shouldn't contain the phrase image of or the word picture. Image is the inherent role, and that context will be announced alongside the alt text. What should be provided is a short, descriptive label describing the meaning, purpose, and intent of the image. To help figure this out, W3C provides an alt decision tree that describes how to apply alt text in given situations, and I'll be linking that resource at the end. This rule, anchor has content, checks for anchors or links to have an accessible name. The accessible name is what is read by screen readers for an element along with its role. The accessible name can be provided by text content, an ARIA label, or a child element with text content or an ARIA label. Similarly, the heading has content rule checks for headings to have an accessible name. In Angular, we have the elements have content rule that is the equivalent of the anchor and heading have content rules in the other plugins. This rule checks links, buttons, and headings to have an accessible name and allows that name to be provided by the text content, an ARIA label, or a child element with those properties. This rule, label has associated control, validates that form control labels conform to the WCAG 412 name role value criteria by verifying that labels are associated to form controls to provide their accessible name. This rule validates labels with implicit associations by looking for a form control element inside of the label. There's also a configuration option to support nested associations if you have any custom form controls that aren't just HTML. A label with a for attribute that matches the ID of the form control creates an explicit association. This rule validates explicit associations by just checking that the label has a for attribute. It doesn't go looking through the rest of the template really to validate that there is a control for the label with a matching ID attribute, because for ESLint that's not very practical, and for component-based web applications that control might be in another template or component. Static code analysis works best for labels when we have nested controls where the implicit association can be validated within that single HTML node. The label has for rule in view is the comparable rule that is similar to label has associated control. This rule used to exist in the JSX and Angular ESLint plugins, but it has been deprecated, and it's the predecessor of the previously mentioned label has associated control. There's actually a ticket open as well on the Vue.js accessibility plugin to also deprecate this rule and move to label has associated control so that we can have a similar rule set and similar functionality. Because another thing to note about this rule is that with the default configuration, it's looking for you to have both the for and ID and the nested control implicit association. But you can actually configure this to behave like nested, the label has associated control rule, so it can just require the nesting or the for and ID, but you have to apply this configuration on top of the rule set in order to make it behave like label has associated control. This rule, mouse events have key events, assists with keyboard accessibility, and it looks for elements with mouse over or mouse out events that are not paired with a corresponding focus or blur. For example, a tooltip is intended to provide clarification or missing information and needs to be shown for both mouse and keyboard users. And for screen reader users, as a side note, a clarifying tooltip should be connected to its trigger with the ARIA described by attribute. This next rule, click events have key events, similarly checks that elements with click events without key events that do not otherwise have built-in keyboard support from the browser, such as a button, it ensures that they also do support keyboard interactions. So HTML elements that support interaction do have built-in keyboard support. So for example, like a button, when it has focus, it can be activated with the enter or space key, and that means it's the same as clicking it with the mouse. So you just need that click event on the button. An anchor link with an href, it has to have the href or router link in Angular, since I'm an Angular enthusiast myself. The anchor link can also be activated with the enter key. So not only does keyboard support make interactive controls more accessible for keyboard users, but it also enables assistive technologies, like when a screen reader announces information about the focused element or a switch device is used to navigate a web page. However, I do want to note that this rule's suggestion to add a keyboard listener to elements that are not inherently interactive doesn't quite improve accessibility for all users. For starters, non-interactive elements that don't have keyboard support also can't receive focus by default. So this next rule, interactive supports focus should be applied on top of click events have key events, and it validates that interactive elements are actually able to receive focus, either because they have that built-in keyboard support from the browser, or you can add a tab index to include them in the focus order. While this rule does pass with a tab index is not actually the suggested fix because it's not really appropriate to just throw in tab index wherever. In order to satisfy the WCAG 412 name role value criteria, you shouldn't add tab index to elements that don't have a label that describes the contents and a role to specify what the element is semantically. If you do have these violations, for this rule or the previous click events have key events rule, you should instead look to use semantic elements that already have built-in keyboard support, or if you're using custom interactions, make sure you're following the Why ARIA Authoring Practices Guide, which is another resource that I'll be linking at the end. Beyond ensuring keyboard support, the no static element interactions rule strictly requires an element with click or mouse events to be semantic HTML elements with an inherent interactive role or to have an explicit ARIA role assigned in order to meet that WCAG 412 name role value criteria. This rule ensures accessibility for users of screen readers and other assistive technologies that rely on the Accessibility API. Speaking of the Accessibility API, next up are a few of these rules that concern ARIA roles and attributes. ARIA is an acronym for Accessible Rich Internet Applications. The purpose of ARIA is to provide information to screen readers and other assistive technologies. The first rule of ARIA is that no ARIA is better than bad ARIA. If an HTML element with the required semantics and behavior already exists, you should be using that. Invalid use of ARIA can actually misrepresent an element's functionality and cause confusion for non-visual users. So if you're using ARIA to present information to the Accessibility API, be sure to follow the Why ARIA Authoring Practices Guide to create a consistent experience for users of these assistive technologies. And I would also recommend that if you're using ARIA, that you build it into shared components implemented with ARIA rather than littering ARIA roles and attributes throughout your feature application. This rule validates the ARIA role attributes to be using valid ARIA roles. It's a great one to pair with the previous rule for validating ARIA attributes. An ARIA role defines what an element does. Semantic elements have an implicit ARIA role. Then it's best to use those well-supported native HTML elements wherever you can. In your IDE, with an ESLint extension enabled, when you mouse over a violation with this red squiggly, a suggestion will be provided. This rule checks for elements with ARIA roles to have the required ARIA attributes. There are some ARIA roles that have required ARIA attributes to communicate state and other information to the Accessibility API, such as the combo box role that requires the ARIA controls and ARIA expanded attributes. Some roles actually have built-in state if used with the appropriate semantic elements. So, with the role switch applied to an input type checkbox, the required ARIA attribute ARIA checked is implied by the checkbox's check state. Problem solved. This rule, role supports ARIA props, validates that the assigned role supports the given properties. Even for semantic HTML elements that have an inherent ARIA role, like this input type radio. ARIA invalid is not a valid ARIA attribute for radio buttons. These are some of the additional ARIA rules that are so far only available in the React JSX accessibility plugin. These rules can be applied incrementally to improve ARIA and usage of semantic elements in an existing codebase, such as not allowing an element with an inherent non-interactive role, like a div, be assigned an interactive role, like a button. Automating these lint rules gives developers accessibility guidance early in the development lifecycle, even before running their code. In my experience, having applied these rules in large code bases, developers are educated about and become more aware of accessibility from the start of a project. Lint rules can run automated checks and they'll perform fixes on our code as well, but human factors play a significant role in accessibility and software testing to ensure that products are designed and developed with consideration for all users. So this next section describes how we can use testing library and unit tests to mimic user interaction and automate validation based on how components are actually being used. Testing library is a utility for testing DOM nodes. It gained popularity with React, but there are testing library wrappers for other frameworks like Angular or Vue, and in addition to many more. Testing library is commonly used in unit testing with Jest and JS DOM, but can also be used with other test runners and frameworks. Testing library queries the DOM in accordance with how a user would interact with a page. It finds links and buttons by their text content and form controls by their label text. Writing tests that interact with the DOM rather than the component implementation details, and in the same way that a user would use a component, gives us more confidence that those tests ensure a component does what it is supposed to do when it comes to your real users. Testing the interface rather than the implementation makes for more maintainable tests and results in tests that shouldn't necessarily have to change if the implementation is refactored or modified. What we're validating with accessibility testing are the programmatically determinable user outcomes, specifically the structure of HTML elements and those attributes that are used by user agents and assistive technologies to extract and present information like the semantic markup, DOM structure and relationships, ARIA roles and attributes, accessible names, and alternative text content. Tests should have assertions that run against interactive elements like inputs, buttons, and form controls, and they should validate that all controls have the expected labels to provide their accessible names. They should simulate user events such as hover, type, and click, and then make assertions on the expected user outcomes. Testing how the interface is used is more inclusive because these tests are accessible by default. After setup and rendering, the first step in a test is typically to query the elements under test, as in the elements that a user interacts with or those that have expected user outcomes. Testing library defines a priority order for using queries that reflect the experience of visual or mouse users and those that use assistive technology. Let's take a look at each of these queries to understand more about why they have this precedence. By role should be your top choice for querying elements in your UI. Use the name option with this query to filter elements by their accessible name, which also supports regular expression, as I have here for case insensitivity, for example. The HTML elements, like button, that you'll be querying for in these user interaction tests already have an implicit role defined. So I don't want you thinking here that you need to add role attributes into your templates in order to find these elements like you might have been doing with test IDs, for example. ARIA roles are a predefined property of semantic HTML elements. Querying by label text validates that you have a label associated with your form control to provide the accessible name. By display value, we'll query form fields by their filled-in values. By placeholder text, queries form fields, as you may have guessed, by their placeholder text. However, for your users, a placeholder is not an accessible substitute for a label. A placeholder typically does not serve as an accessible name, and it's no longer visible once the user starts typing into an input, so it should not be used as instruction. By text should be used to query for non-interactive elements by their text content, such as text in a paragraph or a span, aligning to how users read text on a page. By alt text queries images by their alternative text content, and it validates accessibility for non-visual users. This query by test ID, it's not accessible and it's not otherwise advised to use with testing library, except in cases where it's not practical to match by role, label, or text. Test IDs are an escape hatch, not a front door. Test IDs are not being presented to your users, and they're not a part of the user experience. Not directly related to accessibility, but while we're talking about testing library, I also want to mention that the get by examples I've been showing, in addition, testing library provides these additional variants. So there's one set of single element queries, and then another set of all by queries that will return an array of elements matching that query. And then there are the get, query, and find query types, the difference being that get will actually throw an error if the query doesn't find any matching elements, and that error is actually really helpful to help you track down why it's not finding the element, so you really want to see that feedback in the error if you're getting it. Whereas the query will return null if there are no matching elements found. So because the get by methods will throw an error, but the query by APIs will make an assertion that returns null, you want to use the query by to check for elements that are not expected to be present in the DOM. Find queries, then, on the other hand, are asynchronous. And for Angular, they will actually trigger a change detection cycle for you as well before querying for a match. Find is a combination of get and wait for with testing library, and it will retry looking for elements up to 1,000 milliseconds, which is the default timeout. And in Angular, for example, this can be actually really helpful for avoiding the use of fake async in your tests. So once you've queried for and gathered the elements under test, following the arrange, act, assert pattern, the next step is to perform some user interaction on those elements. User event is a companion library for testing library. Testing library also includes a fire event API for dispatching single events, but user event is often preferred because it provides methods that more closely resemble actual user interactions by trying to simulate all of the real browser events that would happen as the user interacts with the elements. User event describes full user interactions rather than distinct events. As part of its validation, user event checks that elements are actually visible and can be interacted with. For example, it takes into account that browsers don't actually allow clicking on a disabled button. Another nice thing for Angular, again, is that user event will actually run a change detection cycle for you, so no more fixture detects changes. So for example, user event hover will simulate hovering over an element by triggering the appropriate mouse over and mouse enter events. And then click will first hover that element, and then it performs all of the mouse pointer interactions to do the click. The type replicates a user typing into an input element by first focusing on the input, then it will do the key down, key up, change, and input events. To simulate the browser, user event needs to mock the UI layer and apply workarounds on top of the test environment to mock trusted browser events that are not otherwise available in a virtual DOM environment, such as the clipboard, which is then replaced by a stub in the setup. So the user event setup function should be called to invoke and start a session and configure an instance of user event, applying these workarounds and the configuration from the beginning before the component is rendered. Setup was actually added in version 14 of user event, and so for backwards compatibility with prior versions, the user event API methods can be called directly, but then they will each invoke the setup under the hood. So far, with testing library, we've covered using queries that are accessible by default and automating simulated user interactions for our tests. Finally, we need to make assertions on the expected user outcomes. Expected user outcomes in software testing are defined by the ideal results that should be fulfilled once a test case has been executed. The outcomes that are tested should be relevant to the user impact and how components are actually supposed to be used, rather than testing internal component implementation details. To that effect, JESDOM is another companion library for testing library that provides custom DOM element matchers for Jest. JESDOM's custom matchers actually allow you to write these tests based on user interactions or user outcomes with human readable assertions. So your tests actually become pretty apparent in what they're trying to do and what they're asserting. Once installed, you'll want to import the JESDOM in your test setup, and then those matchers will become available in all of your tests. JESDOM's matchers don't actually require that your queries come from testing library. It actually does work with any DOM-based testing library or framework. So first off, to be in the document is your basic assertion that an element was rendered. The to be visible assertion also checks that an element was rendered, and in addition to being present in the document, it checks the element not to have display none, visibility hidden, or visibility collapse, or opacity of 0. It checks for the element not to have the hidden attribute. The parent element must also be visible according to these parameters, and if you have a details HTML element, it must have the open attribute. But an important thing to know here with JSDOM is that it doesn't actually render the component CSS by default, so with the to be visible assertion, it won't match these CSS properties unless they're like inline style or you have styled components. So more often, it's actually better to test for visibility with a testing framework that actually runs in a full application in a browser, such as Cypress or Playwright, which we'll be talking about next. These next matchers check an element's attributes, classes, and inline styles. Inline styles are rendered by JSDOM, and they can be validated with the to have style matcher. And so even if your CSS isn't applied, you can use the to have class matcher to make assertions on conditional classes. So if you have a class that affects the visibility, as it's most common to be using testing library in JSDOM that doesn't have the CSS rendered, rather than the to be visible matcher, you'd want to use the to have class matcher to validate that element's visibility. The to have focus assertion can test that expected element has focus, or on the other hand, that elements that are not visible or disabled are also not able to be focused or navigated to via the keyboard. Certain focus behaviors are expected in single-page applications, such as when a modal is opened, focus should be positioned and trapped within the modal, and when the modal is closed, focus should be returned to the previously active element. Here, I've got an example test for validating that the focus is not reset after navigation in a single-page application. So first we're going to render the component with testing library, and this is React, so we're going to need to apply the browser router wrapper. We'll click the first link in the nav and wait for the location to resolve to the routed path. And then after navigation, we'll assert that the navigated link still has focus. We'll tab over to that next link using the keyboard, and then we'll use the Enter key to navigate that focus link. So we're having both keyboard and mouse events in our test to validate accessibility. And then after navigation, we'll assert that that second link also still retains focus. So these next matchers, to be disabled and to be enabled, check for the disabled attribute on HTML elements. It doesn't apply to ARIA disabled, which doesn't have the same behavior as the disabled attribute. Disabled controls are not focusable and they're not clickable. And only certain elements can be disabled. We got button, input, text area, select, option, op group, field set, as well as perhaps your custom elements. The disabled attribute does not apply, for example, to links. To be enabled works the same as not to be disabled, and it helps us to avoid the double negation of not disabled. An element's ARIA role will define the semantic meaning or type of a UI element. The to-have role matcher can match either an explicitly assigned ARIA role, such as assigning the role switch to a checkbox, or it will also match an implicit role like the text box role given to text inputs. The accessible name conveys the context and meaning of an element, and it distinguishes it from other elements on the page. Accessible descriptions are typically optional, and they are used to provide additional information or instruction. So for example, an element's accessible name can come from child content, as we have here, with a button that contains text, or an ARIA label, as I'm showing with this input with the ARIA label search, or by referencing content with ARIA labeled by. Form controls should be paired with a label for the accessible name. Here, we're testing both the implicit associations with nested form controls and explicit associations with the for and ID attributes. A field set with a legend provides the accessible name to a group of form controls. And tables should have a caption element for their accessible name. ARIA label does work for all of these too, but it's important to note that visible labels improve accessibility for all users. Accessible descriptions then can be set by the ARIA description attribute or by referencing an element with ARIA described by. ARIA described by works similarly to ARIA labeled by, where you assign it the ID of an element that contains a visible text description. If an accessible description is provided, it should give additional context or instructions, and it should not repeat information from the accessible name. Descriptions can also be provided with the title attribute on links or form controls. However, the HTML title attribute is not shown to keyboard or mobile users. So I will say it again because it's worth repeating. Visible text descriptions provide accessibility for all users. When in doubt, you can expect accessibility properties like name and description in the Chrome or Firefox DevTools. In Chrome DevTools, there's an accessibility pane incorporated into the Elements Inspector that allows you to view the accessibility properties and ARIA attributes. In Firefox, the Accessibility Inspector is a separate panel in the DevTools. These ones are the structural matchers. To be empty DOM element is commonly used in the negative, such as not to be empty DOM element. To contain element checks whether elements are descendants of other elements. To contain HTML checks whether an HTML string is contained in an element. However, testing specific DOM structure can be very implementation specific, and it's not really how a user experienced the application. So it's better to assert on elements over which you have control if you have these needs with to contain element. To have text content is an assertion that does actually align with user experience. So you want to use to have text content for non-interactive elements with text content, such as paragraphs or spans. These matchers check for the ARIA invalid attribute, and for form elements to conform to any required type, pattern, min-max, and min-or-max length constraints. The to have accessible error message checks whether the element has an ARIA error message attribute that references an element with the given error message. And the rest of these matchers are also for making assertions on form controls. I'm starting to run out of time, so I'm going to just click through the example real quick that I wanted to let you know how nice it is to write tests with testing library and how they become readable and they really communicate their intent. Before we finish here, I do want to introduce Playwright with Axe Core. Axe Core is a fully automated testing accessibility testing engine, and it is a package that can integrate with Playwright, and which is a popular end-to-end testing framework. This will inject the Axe Core engine into a page and run an exhaustive set of automated checks similar to what you might get with the Axe DevTools browser extension. The Axe Core accessibility testing engine automatically applies all of these rules wherever it is called to check accessibility. And because these rules run against a fully rendered application, they can look for best practices, like proper page structure, ensuring every element has an H1 heading, and that headings are in hierarchical order, that there is only one of each of the main, banner, and footer landmarks, and that other elements that are landmarks have unique names, and that all page content is contained within a landmark. It also validates ARIA usage, checking for valid, required, and allowed ARIA attributes, and required parent or children for an ARIA role. This is actually all the code that it takes to inject Axe and run all those rules against a page. You import the Axe builder from the Axe Core Playwright package, navigate to that page, which you typically do in the before each, instantiate the Axe builder, and then await on the analyze to run the accessibility scan. Finally, you assert that there are no violations in the results. The Axe Builder configuration also allows you to filter the scan to specific parts of the page, limit the rules to those tagged with explicit WCAG success criteria, or you can also disable certain rules for known issues until they can be resolved. When the tests run, if the Axe Core tests don't pass, they'll log out violations of each rule along with the DOM markup where the violation occurred to help you track it down. Playwright and testing library share a very similar testing methodology. You test according to what users will see or interact with on a page. And similar to testing library, Playwright recommends using the get-by-role locator to find elements on the page. Playwright's web-first assertions validate expected user outcomes. They are async and they'll wait and retry as needed until the expected conditions are met. The default timeout for these assertions is 5 seconds. Locating elements with user-facing attributes and explicit contracts such as the page get-by-role makes tests more resilient to change. The other locators such as get-by-test-ID or locating by a CSS selector are not part of the user experience, and they can be more likely to break if the DOM or design changes. Many of the Playwright assertions may also look familiar to the JS-DOM matchers. So the different levels of testing that we've talked about in our project make up the testing pyramid. The point of the testing pyramid is to encourage us to write tests with different granularities and test less as the level increases with fewer end-to-end and lots of unit tests. If you were in Corey House's talk this morning, he did a pretty thorough job of defining this and that we should, agree on what words mean. So end-to-end tests run against the entire system. They're the most comprehensive, but they also take the most time and resources to run. Integration tests validate that components work together, but they can be slower to render pages and make the HTTP requests. The difference between end-to-end and integration tests is how much of the system is under test. Parts of the system are tested in conjunction with each other in integration testing, which means that some services or components may be mocked out or not otherwise involved. End-to-end tests run against the system as a whole. Playwright is an end-to-end testing framework. But in practice, we often mock out services or simulate APIs or different environments, which does put it more at the integration level. Unit tests, like those we looked at with testing library, validate a discrete unit of code to ensure the unit behaves as intended. Unit testing shouldn't depend on other components or services in the UI, and unit tests are generally faster to run and provide more specific feedback, but they can only find problems at the individual unit level and can't test the system as a whole. Unit tests should run earlier because they're in closer proximity to the components and they can expose problems more quickly. Today, I've also talked about an additional level of testing, static code analysis tools like Angular ESLint, or with like ESLint, take this back one step further and validate the code itself before it runs to ensure that developers adhere to standards like code formatting, naming conventions, and type safety in addition to the accessibility standards we covered today. TypeScript, for example, is a static type checker. Static tests are relatively inexpensive and help guide developers in best practices up front as they're writing the code. Ken C. Dawes has an alternative model to the testing pyramid that he calls the testing trophy, and it favors integration over unit testing. The idea is based on writing tests, not too many, mostly integration. Integration tests give you more confidence than unit testing. When it comes to accessibility testing, being technically correct, though, is not really enough. Manual testing still needs to be performed to ensure that you're using semantically correct code. This can't be fully detected automatically. All interactive elements must be accessible with a keyboard, and you need to arrange your content in a logical focus and reading order. So some of these things need to be checked by manual testing, like that your link targets are clearly identified, that your document is structured appropriately and can be read without style sheets, and so on. So that's about all I have for you today, but I wanted to share those resources that I promised, and if your internet's not working in here, feel free to take a photo, and those are the URLs. The W3C Web Accessibility Initiative, which I mentioned, has great tutorials on developing accessible web content, and I highly recommend that tutorial on page structure. I so often reference this image alt decision tree. And then there's also that Why ARIA Authoring Practices guide with a complete set of design patterns and examples. So thank you so much.